Now that we are comfortable with selection sort, we can begin implementing our own solution to the algorithm. So to start off, we know that we need a vector that we are going to want to sort. So we will say let mut array, and we will give it a type of vector storing i8s, and then we will create it. And we want to use the same values that we used in the previous lecture. That way we can verify our results and understand how our algorithm was able to sort the values in ascending order. So something else that I want to do is I want to print out the values before and after we sort, just to make sure that everything was done properly. So we have before sorting, and we were going to pass in our array, and we'll copy and paste this, and we will change this to after sorting. So you can see by my print line statements that I'm using the same variable in every location. So that means that I am going to use selection sort, and I'm going to pass in a mutable reference to our array. So now we can begin implementing in our function called selection sort. So we're going to pass in our array. We know it's going to be a mutable reference of a vector that is of type i8, and we want to return our vector that is an i8, that contains i8 values. So we looked at the pseudocode and we knew that we had two for loops. So I will go ahead and start with the first one. So we will start at index 0 and go to our array length -1, which is following what we did in our pseudocode. And now we want our smallest variable, or value, excuse me, to be equal to I, and we need it to be mutable because remember, if an index is less than our current smallest, then we need to update our current smallest value. So therefore it needs to be mutable. That way we are able to update it. So now we're going to do I plus 1 all the way to our array dot length again, but this time we're going to go to the end of the array. And so now we can do our checks. So if array of j is less than our smallest value, is less than the array of smallest, then we want to set smallest equal to j. And now, once we exit out of the loops, we want to swap, and luckily there is a swap function for us in the vector methods. So we want to swap our smallest and our I value, and now we want to return our array, and we have to say array to vec. So now we have our array and our selection sort set up. So let's execute this code to make sure it runs correctly. So we see before sorting we have 4, 3, 1, and 2, and then after sorting we have 1, 2, 3, 4. So that looks correct. Let's do one more test case to make sure everything looks good. So we will say let mut array2 of vec i8 equals to vec, and let's do our second test case that we did in the previous lecture. So we have 5, 10, 1, 4, and 11, and now we want to print out the same messages as before sorting. And we're going to do our second array. We will call selection sort on a mutable reference again to our array2, and now we will do our print line again and say after sorting array2. So we now expect this to be printing out two arrays for us. So we have our first array, which we already know is correct. And now we have our second array of 5, 10, 1, 4, and 11. And we see that after running our selection sort algorithm, we have 1, 4, 5, 10, and 11. So we are confident that our selection sort algorithm is correct and is correctly sorting the vectors we pass into ascending order, so into increasing order. So we are confident that our solution is correct. So in the next section, we will continue on learning about additional sorting methods. And remember, if you have any questions at any point during any of the lectures, please feel free to ask them in the Q&A section.